Welcome to the deep dive. Today, we're going to be looking at battery tech,
Oh, yeah.
specifically a concept called Nlevel.
Okay.
And this has the potential to completely change how we think about energy storage.
Yeah, it really is a fascinating shift when you
Yeah.
think about it. Everything from electric cars
Right.
to how we power our homes could be impacted by this.
And we're basing this deep dive on a presentation by Gerald Bode.
Oh, okay.
He's a real trailblazer in the field.
Hmm.
Um, he introduced Nlevel at the Battery and Power World 2023 conference,
Okay.
and his talk is available on YouTube if you want to see it yourself.
Awesome.
Yeah.
So Bode starts by laying out a problem that
Yeah.
you might be familiar with.
Okay.
Traditional battery systems have a major weakness. They depend on serial connections,
Okay.
meaning every cell in the battery is linked together in a chain.
Like a chain.
And like any chain, the entire system is only as strong as its weakest link.
So if one cell isn't performing well, the entire battery pack suffers. That's exactly what happened to Bode with his Tesla.
Oh, wow.
A single faulty cell caused the whole car to shut down.
Really?
Can you imagine that happening to you?
That would be awful.
I know.
It highlights the limitations of serial connections.
Yeah.
The weakest cell dictates the performance of the entire pack,
Oh,
leading to inefficiencies in charging and discharging.
so you're always limited by that weakest link.
You are.
Okay.
Plus, large battery packs with high voltages present a safety risk if a single cell fails.
Okay, so traditional battery systems have limitations.
They do.
Enter N-level.
Okay.
Bode's concept focuses on modularity and treating each cell as an independent unit.
Got it.
It's kind of like giving each cell its own brain to manage its charging and discharging.
It's a revolutionary idea.
Yeah.
This modularity has so many potential benefits.
Okay.
For instance, you could have a battery pack with cells of different capacities and ages.
Oh.
Instead of discarding an entire pack because a few cells are weaker,
Right.
you could integrate newer cells with older ones.
Maximizing their use and reducing waste.
That sounds amazing for sustainability and cost effectiveness.
It is.
You wouldn't have to replace an entire battery pack as often.
Exactly.
Wow.
And the flexibility goes beyond just mixing and matching cell types.
Okay.
N-level modules can be configured to provide a wide range of voltage and power outputs, meaning they could be adapted for tons of different applications.
So Nlevel could power anything from a small device to an entire house.
Absolutely.
Wow.
And because each module is independent,
Yeah.
you could hot swap them for continuous operation and easy upgrades.
So it's like replacing an ink cartridge in a printer,
It is.
except this time it's for energy.
Exactly.
That makes a lot of sense.
Yeah.
I can already imagine the possibilities.
Uh-huh.
But what about safety?
Okay.
That's always a concern with batteries.
All right. N-level addresses those concerns head-on
Okay.
by operating at lower voltages at the module level. The risks associated with traditional high-voltage packs are minimized. So it's safer because each individual unit is operating at a lower voltage,
Right.
even if the combined system is high voltage.
Precisely.
Okay.
Now,
Yeah.
let's shift gears a bit
Okay.
and look at how Nlevel could work in the real world.
All right.
Bode shared some fascinating examples in his presentation.
Okay.
One that really caught my attention was using car batteries to create a makeshift power system during a disaster.
Oh, he specifically mentioned the Fukushima incident.
Yes.
Remember how the lack of standardized connections for different battery types created huge problems during rescue efforts?
Absolutely.
Yeah.
And Nlevel's modularity could have been a game changer there.
Oh, wow.
Imagine being able to connect various batteries from different vehicles to create a reliable power source in an emergency.
Wow.
That's the kind of adaptability and resilience Nlevel could bring.
Wow, that's incredible to think about.
It is.
They could really empower communities to handle difficult situations.
Absolutely.
Yeah.
But the applications go beyond emergency situations. Think about electric vehicles. What if Nlevel modules were integrated directly into a car's frame? You could add more modules for longer trips or adapt to different charging stations easily.
So instead of being limited by a fixed battery capacity,
Right.
you could customize the range of your electric car.
Exactly.
That would make a huge difference, especially on long road trips.
It would.
And imagine if you could even use your car's battery to power your home during a power outage.
Now you're talking.
You're saying my car could become a backup generator.
You got it.
That's amazing.
That's the kind of integration Nlevel allows.
Wow.
You could potentially have a seamless energy system
Hmm.
between your car, your home solar panels, and your home's battery storage.
So we're talking about a complete transformation of how we think about energy at home.
Yes.
And Bode didn't stop there. Right.
He didn't.
He even talked about how Nlevel could be applied to renewable energy on a larger scale.
Exactly. He envisions these modules being connected directly to solar farms and wind turbines, simplifying grid management and smoothing out the variability of renewable energy sources.
Nice. So instead of needing complex systems to handle fluctuations in solar or wind power,
Right.
N-level modules could act as a buffer, storing energy when there's an excess and releasing it when needed.
That's the idea.
That could be a huge step forward for renewable energy adoption.
It would.
Wow.
What's really interesting is that N-level could even simplify the transition to higher voltage systems,
Okay.
which are becoming increasingly important in electric vehicles and grid infrastructure.
But wouldn't higher voltage systems require more complicated and potentially dangerous electronics?
Traditionally, yes.
Yeah, I'm thinking about safety again.
Right.
Huh.
But with N-level,
Yeah.
the beauty is that the voltage at the module level stays relatively low.
Okay.
Even if the entire system's voltage is high, you get the efficiency of a high voltage system combined with the safety of lower voltage components.
So it's like having the best of both worlds, high power and efficiency with less risk.
Exactly.
That's impressive.
It is.
Okay.
It's a fascinating approach to solving multiple problems at once.
Wow.
Now let's dive a little deeper
Sure.
into the advantages of N-level, first and foremost.
Yeah.
There's the increased efficiency we touched on earlier. By minimizing energy loss during charging and discharging,
Right.
N-level could make our energy use much more efficient.
That's a big deal considering how much energy we waste with traditional systems.
Absolutely.
Yeah.
And then there's safety,
Okay.
which we've already discussed.
Right.
N-level significantly enhances safety by operating at lower voltages
Okay.
and allowing faulty components to be isolated quickly.
So even if a module fails, the rest of the system can continue operating safely.
Exactly.
Well,
The impact of a failure is minimized, and there's no risk of a cascading failure that takes down the entire system.
that's reassuring to hear.
It is.
What other advantages are there?
Well, there's the inherent reliability of the system.
Okay.
By eliminating single points of failure, N-level becomes much more robust and less prone to downtime.
It's like having a backup system built right in.
Exactly.
Wow.
And then there's the flexibility and scalability we've already discussed.
Yeah.
You can adapt an N-level system to a wide range of applications and easily expand it as needed.
It's like a plug-and-play solution for energy.
It is.
It sounds like something out of a science fiction movie.
It's certainly a futuristic concept.
Yeah.
And the last major advantage is the potential for cost reduction.
Okay.
Streamlined manufacturing and a simplified system design could lead to significant savings compared to traditional battery systems.
So it's not just about better performance. It's also about
Yeah.
making clean energy more affordable for everyone.
Precisely.
Wow.
When you connect all these advantages, it becomes clear that N-level could accelerate the adoption of renewable energy in electric vehicles,
Yeah.
which is a big step towards a more sustainable energy future.
It's incredible how one innovation could have such a ripple effect across so many different areas of our lives.
It really is. And it all stems from this beautifully simple idea of modularity and intelligent cell management. But the story doesn't end there. There's still so much more to unpack with N-level.
Okay. It's mind-blowing to think about how something like a battery could have such a huge impact.
Yeah.
Bode even gets into some pretty technical details about how N-level works.
Right.
And there were some parts I found particularly fascinating.
Okay.
For instance, he talked about how you can create different voltage levels and even specific types of electrical current using this modular approach.
It's not just about slapping a bunch of batteries together.
Right.
Bode's talking about actually creating AC power directly from the modules without the need for those bulky inverters we typically rely on.
Wait, so you're telling me that N-level could potentially eliminate the need for inverters altogether. How does that even work?
It's ingenious, really.
Yeah.
Think of a symphony orchestra where each musician plays a specific note at a precise moment to create a complex melody.
Okay.
N-level does something similar. It coordinates the switching of individual modules on and off in a specific sequence, mimicking the alternating current waveform.
So you're saying that by precisely controlling which modules are active at any given time, you can actually create an alternating current directly from the battery.
That's the idea.
That's amazing.
And the results he showed in his presentation are quite impressive.
Yeah.
The waveforms generated are clean, and the switching frequencies are remarkably low, which means less energy loss and higher efficiency.
Wow.